I'm Jessica Philippe. I'm the Member Engagement Librarian at SCRLC. Today's program is the fourth in a series that we're hosting on preparing for the April 8th total solar eclipse. This series is supported in part by the American Astronomical Society's J.M. Pasakoff Solar Eclipse Mini Grants program. So we have two speakers today to tell us more about Eclipse Soundscapes and Dark Sky International. So first up, we have Charles Falco. Charles is a science teacher, and he's the American Astronomical Society's 2024 Solar Eclipse Education Coordinator. So welcome, Charles.
That's great. Thanks, everybody. Welcome to 34 days and change before one of the coolest, well, no, the coolest thing you'll ever see in your life, a total solar eclipse. I have been a veteran, luckily, of five prior ones. Four of them I've seen. One was a washout. And that was an interesting one I'm going to get to because dark skies were unfortunately not involved in that. And I'll tell you more about that shortly. For those of you who have never seen a total solar eclipse, it is by far the coolest thing you could ever imagine or can't imagine because it is an unworldly thing. Your brain has a hard time trying to make sense of it. And when I try to remember how things looked and how it felt, it's just so surreal that you have to really rack your brain to remember exactly what it looks like. And again, my mistake was always trying to photograph it and taking measurements and doing too many things and not just looking at it. So this time I'm actually not even going to use a camera at all. I'm going to just just watch it and enjoy it because I've never done that before totally. So I'm excited about that. So this is real quick. I want to just show you a little slideshow I did here. And unfortunately, it's not where, there we go. Okay, now it's working. Okay, this is a video I did of from South America in 2010. And it's, unfortunately, the audio for some reason is not working. But watch what happens to the left side of the screen. You're going to see the oncoming lunar shadow coming at over 1,000 miles an hour towards you. And it's one of the most eerie, almost scary things you can imagine. All of a sudden having this wash of blackness come over you. This eclipse took place close to sunset, so the shadow is very elongated, and you could see a lot of brightness in the sky on either side of the shadow's edges. And there's totality. And again, this is, I even hate to show videos of totality and eclipses because it doesn't do it justice at all. To really appreciate an eclipse, you have to be there. You have to feel the shadow coming at you. You have to see people getting eerily quiet, or some of them start crying. It's just such an unreal thing. And there's the solar corona, which again looks nothing like this. The corona is actually translucent. You can see stars through it. This is a little more yellow because we were near the sunset point of the eclipse path. But again, it's just such a cool thing to see that if you haven't seen one, you don't know what you're missing. And if you have seen one, you know exactly why you want to see them over and over again. So I'm going to just do a little eclipse basics and then some dark skies basics. Okay, so total solar eclipses aren't necessarily that rare. They occur about every 18 months or so someplace on the globe. But if you were to stay in one location, you would have to wait about 375 years on average to see another one come around again. So for New York State, for instance, we've the last one we had was in 1925, and that was total over Buffalo, Ithaca, Binghamton, Poughkeepsie, and then parts of Manhattan and all of the Bronx and my own hometown of Port Chester. We have to wait until after this one, we have to wait until 2079 for another totality to occur within New York State. 2045 is going to be a big one. That's going to cross the country, but that's going to be far south of us. They're calling the Disney World eclipse because it will be total over Disney World. When you have an eclipse, it's not like black as night, except one time that happened, and I'll explain that. But you do see a kind of a very deep twilight. You get changes in animal behavior, changes in human behavior. It's just such a crazy thing to see. And the sheer coincidence of it all is amazing because you have an object that is the sun that is 400 times larger than the moon, but the moon coincidentally, and one of the great coincidences of nature in the universe actually, is 400 times closer to us than the sun is. So that magical geometric coincidence causes the moon to be perfectly aligned with the sun. And of course, they have to be both round, which doesn't necessarily happen in our solar system. You have oblong shaped moons, so the whole thing is just crazy. It's the fact that we can even experience one is mind blowing when you realize all the things that have to have happened. So here's a very not to scale diagram. I always say not to scale because number one, the moon is not in a circular orbit, and if the sun were that close to us, we wouldn't be here talking about it actually. So this is just more for demonstration purposes. Again, here's the really cool thing. You have a moon that is just about the same size as the sun. And that's why total eclipses, even when they're total, they don't last very long because the moon is not that much larger than the sun when it can totally eclipse it. Sometimes the moon appears smaller than the sun, in which case you have what's called an annular eclipse. So again, the fact that we can see totality at all is just astounding to me. Um, here's how that works. You can see the tennis ball representing the moon, and as you draw the moon closer, it can actually eclipse something much larger than itself. And again, when you're demonstrating to people, grab whatever's around you. I use the clock in my classroom as the sun. I use students' thumbs as the moon, and your eye is the earth, you on the earth. And you, as you bring the moon in and out, you can see that it grows larger and smaller, sometimes being able to cover the clock and sometimes not. Hey, this is a kind of a cool vision of the eclipse. This is from looking in from the sun on the far side of the moon. And you can see that the moon's got a very conical shadow and it tapers away to next to nothing. It's lucky it even hits the earth. It's such a magical alignment. If the moon were much larger, it would cover the corona, as we're going to see the corona appearing very tenuous and very beautiful. If the moon were much larger, you would miss the corona. And if the moon were any smaller, you wouldn't have totality at all. And again, here's your shadow. Shadows have two parts, the darker umbra, which is the part that you have to be within to see totality, and the lighter penumbra.
Are you good?
I'm going to skip through this because actually I'll show you this. This is a time-lapse photography of the moon from 2017. You could actually see it going just across the US from Oregon to South Carolina. That was a beautiful eclipse. And luckily this eclipse is about twice as long in some places. So that's really cool. You have to be within the path of totality from Texas to New England in order to see the sun completely covered. Ithaca gets about 99% or thereabouts. The good news is you're so close to totality that you could just drive over a few miles probably, but you really want to tuck yourself into the center of the shadow just to give yourself maximum minutes of totality. Again, a lot of people think 99 point something percent is a really good eclipse number. Well, it's not. It's actually ironically, the closer you get to totality, the more people think, oh, wow, this is great. I don't have to move. Ironically, you should really get in your car, get your school kids in a bus, drive into totality, because I'll show you in a few minutes what you're going to miss if you don't do that. Again, there's lots of sites. This is called time and date. It shows you exactly what time it starts, what time it ends. If you get totality, if you don't, Boston does not get totality. See that little sliver of sun at maximum eclipse. So I wouldn't be in Boston that day. I would be farther north in New Hampshire or Vermont. And here's what I'm talking about. This is an eclipse as if you were watching it with eclipse glasses on, no glare. This is from Toronto, which gets about 99.8% partial. You can see just that little bit of sun is left. Okay, so you're thinking, wow, that's pretty cool. I can probably see a lot of stuff with that. And here's what it looks like without eclipse glasses. If you were just basically looking at the sun, waiting for totality to happen. Okay, here's what's going to happen. The moon gets close to the edge, and boom, that's it. You don't see anything. So even with 0.2% of the sun showing, which is not a lot at all, the sun is still thousands of times brighter than totality. So you really got to make sure you get in the path of totality. And I'm clicking here, and there we go. Okay, it's a little dicey today. Sorry about that. Again, now here's Buffalo. Here's Buffalo with glare. Buffalo does get totality, and you're going to see what happens. The big difference now, there's that sliver of sun shrinking, and this is a very dynamic, dramatic part when you feel a light around you fall with about 30 seconds left. And there you go. There's totality. That's what you're missing. You need that. You literally need that 0.1% of the sun to disappear before you get any of the cool stuff with totality. And I do want to talk a little bit about dark skies before I continue with this. I'm going to just go to, should bring this taskbar down here. I can see what I'm doing. Okay. I'm a longtime member of the International Dark Sky Association. They're based in Tucson, Arizona, and I'm sure many of you are familiar with light pollution. How could we not be, right? It's all around us. Light pollution affects pretty much everything in a negative way, from wildlife to our entire ecosystems. It wastes energy. It can affect the climate because of wasteful energy, using CO2 emissions involved with this. Human health, it affects everything from sleep habits to supposedly now they're talking about cancers being escalated because of the lack of melatonin that's produced by a person who is kept awake at night by bright lights streaming into the bedroom. Then, of course, you have crime and safety, which is all about what I call insecurity lights. I know Mary Carroll feels that way too. When you have these lights around ATMs and other buildings, and instead of putting light where it belongs onto the ground, where you could actually see who's around you, you get lost in glare, and the glare actually produces pockets of bright light that actually are beneficial to muggers and burglars and everybody else who you don't want to be around. It can actually keep them from being seen. And again, also, when I give a talk to communities, one of the last things I mention is the lack of being able to see the Milky Way anymore, which to me is a crime. But I tend to see a lot of people don't really care too much about that. So they are more interested in saving tax dollars and saving energy, which is actually admirable. But I hardly talk anymore about the aesthetics of light pollution because more people listen to the cost, benefits and cost savings of having good lights. So what happened was in Shanghai, I was in Shanghai for the 2009 total eclipse, and I was all excited because even though it was raining and cloudy, I knew the footprint of the moon was going to be extra large. It was about a 6.5 minute totality. So I was all excited to see how dark it was truly going to get. Well, everybody in Shanghai, the buildings, the police, the streetlights, they all stayed on. In Shanghai, if you haven't seen pictures of it, it is easily, to me, one of the most light polluted cities in the world. Even the buildings broadcast LED, and this is back in 2009, so we're talking 15 years ago. You had advertisements on the buildings. You had lights all over the place. You had lights streaming up into the sky for ads. It was ridiculous. Like not one of my favorite cities. So the fact when totality hit, all the lights stayed on, and it was a very, very disappointing experience. It was still very dark. We were on an island outside the city, but the glow from the city and the streetlights right around us just destroyed everything. So if you go on to darksky.org, that's a really, really good site. I do talks on this all the time where I talk strictly about dark sky. This is kind of a hybrid eclipse dark sky talk. And again, being that it's a solar eclipse, you don't really have to worry too much about the daytime effects of light pollution, except what happened to me in China. That's why I do tell cities that are going to experience totality, please make sure if there's any way your streetlights can be turned off. A lot of cities don't want to do that. And I had a talk with a Costco in 2017 in Carbondale, Illinois, where I was. I said, please make sure your lights are off. Don't come on, because Costco has some of those obnoxious lights I've ever seen in their parking lots and around the buildings. And they said, oh, I'm sorry, our lights are controlled by headquarters in Seattle. So I said, really, you can't turn them off on your own? No, I'm sorry, we can't. So we had to deal with the Costco lights being on, things like that. So I discovered a lot of things in the 2017 eclipse about being able to turn lights on and off. And I have to say, I wasn't necessarily too pleased. So if you go into darksky.org and just look around, I got involved back in 1991. So I've been with them for 33 years already. I'm what's called a local area director, which means that I can actually help out my community, Westchester County, the Berkshires in Massachusetts, and I have a role in the Keys in Florida where I used to live. So I'm actually a local area director or a co-area director in at least three different locations. There may be more I'm forgetting about, but those are three very important areas to me. The Keys for their marine life, because sea turtles should not have extra lights on at night when they're trying to lay their eggs on the beach. Instead of being drawn to the full moon, they get drawn to artificial light on the shore, and that's not good. The Berkshires is still a relatively dark area in western Massachusetts. I want to keep it that way. And Westchester County is terribly light polluted, but I live there, so it behooves me to take an active role in the IDA. So that's kind of, in a nutshell, what the IDA does. If you go on the website, I'll post this to the chat. I'll do that right now. There you go. And then I want to go back to the eclipse, because the eclipse is a really, truly, I'll say, once in a generation. For many people, it's more like once in a lifetime, or in the case of totality, never in a lifetime. Even though totality does occur, as I said, about every 18 months, it's still very rare, because think about it. The Earth is 3/4 water, 3/4 ocean. So 3/4 of the time, the path on average falls over open ocean, or it's in the mountains where you can't get to it, or it's in the polar regions, or it's in a war-torn country. So this is why the fact that totality is coming to our country in about a little over a month is so amazing, because that won't happen again until 2045, and it won't happen again in New York State until 2079. So that's really important that everybody makes tracks to see this thing. Eclipse2024.org, really good site. It is created by my friend Dan McGlawn from Indiana. He's a whiz at this sort of stuff. This is really cool, because you could actually, if I had more time, I would show this to you. You could actually type in your where you live up in the box here. You like type in, say, I would type in Port Chester, New York. Click on it. Up comes an agree box. You agree to the stipulations about wearing glasses when you need to, and then you go to this screen pops up, and you have all these wonderful special effects you can do. You could drag the image to make it larger. You could slow it down. You could speed it up. It tells you exactly what time totality will hit, how much is showing right now. In this case, 70% of the sun is covered. You have special effects. You could cause glare to happen. You could have planets and stars come out. It's a really great site, and it really does mimic totality quite well for a virtual event. So I would highly recommend, again, eclipse2024.org. And again, this is your basic eclipse. It's just basically the fact. I won't get into this now because I don't have time. In fact, if you could give me a 2-minute warning, anybody, that would be great when I'm approaching the end. The moon orbits at a tilt to the Earth's orbit, so most of the time, the moon is too far above the Earth to cast its shadow on it, or it's too far below to cast its shadow. But every 6 months or so, the moon and the Earth and the sun are right in line, and the moon's shadow falls directly upon the Earth. Again, it could be anywhere on the Earth. The fact that it hits the U.S. Only 7 years after having done it in 2017 is pretty amazing. And there's the tilted orbit of the moon. And you have to have, of course, a new moon, which is the phase of the moon that is between the Earth and the sun. This is my general eclipse lesson that I do. It's actually a lot. There's a lot of stuff that go into eclipses. There's the Saros cycle, which means that every 18 years, 11 days, and 8 hours, you're going to have a very similar eclipse to the one that occurred one interval before that. And again, you'll have one interval after that. It'll be a similar eclipse. The only problem is with the 8 hours, it's going to take that eclipse into a different part of the world, because in 8 hours, the Earth rotates about a third of the way around on its axis. So different parts of the country will experience that almost exactly same type of eclipse that occurred 18 years, 11 days earlier. Again, this made for a really convenient way to predict eclipses into the future. I have my students do this all the time, and they come up with the dates regularly, but you don't know where it's going to be. That's for more complicated math, but it'll tell you at least the date of the next eclipse. It's a cool pattern. And there you see patterns of Saros cycles occurring 18 years, 11 days, 8 hours apart. And I was privileged to see the 1991 event in Mazatlan. I saw, and then I saw the 2009 event in China. And then I'm hopefully going to see the 2027 event over Northern Africa, all part of the same Saros series. So that's really fun to know. math things like this for eclipses. The Babylonians, the Maya, they could predict eclipses too. So it wasn't just the Renaissance that got people involved in eclipses. If you want to observe the eclipse using pinhole viewers, you can make those very easily. You could purchase eclipse glasses from me. I have the best prices in the country, and act now though, because the glass prices to distributors are going up. So I still have a supply left from the older prices. So please, if you want to go onto my site, it's called scienceinsideout.com, and you'll see the ordering page. And I also have a email, totality2024@gmail.com. Younger kids can go under a tree to see an eclipse. There's plenty of ways. Again, I'm posting new things every day on my website as we go. It's a relatively new website, so it's going to be very complete in about a week. So I have all these things that I'm showing here, how to do them. Lesson plans for teachers. I have letters for teachers and parents to plead with the administrator to let the kids out for an eclipse and not let them miss it. I have suggestions. I have places to go. Everything you can need. Why everybody from kindergarten on up should not miss this eclipse by being trapped inside because an administrator said you have to be inside. All the myths about blindness and everything like that. If you look at an eclipse safely, no one's going to go blind. There's plenty of safe ways. You can stick young kids under a tree, watch the crescents on the ground. You could do group viewing like this. And I even had prisoners. These are prisoners that I visited in Houston and taught them how to make eclipse pinhole viewers. And the prisoners actually saw the eclipse outdoors in their courtyard. Here's your crescents on the ground. 1963, kids were outside looking at eclipses. So kind of ironic in 2024, we still have trepidation about viewing eclipses. It's very, very dissettling to me as a teacher. You can make a time capsule, which are fun. There's a time capsule being buried in 2017 at a ballpark. Again, patterns. First graders, according to the NGSS, Next Generation Science Standards, have to be able to recognize patterns in nature. An eclipse is a wonderful way to introduce kids to patterns. Make a sundial. Try to predict where the sun is going to be 3 hours from now. Older kids can equate geometry with patterns. It's a wonderful way to use nature as a learning tool. Again, you could do things like temperature change with a line graph. You can watch animal behavior. You can watch the lighting change with a photometer. You can buy a photometer at any camera store. I believe they still make them. You can watch what the weather does. Do cumulus clouds disappear, as they often do? Plenty of things to do. There's projects nationwide like Eclipse Mega Movie. Again, if you go on Dan's site, eclipse2024.org, my site, scienceinsideout.com, we're going to have all these available as well. There's me working with kids in Naperville, Illinois in 2017, just before the eclipse there. And there's the prisoners in Houston seeing the annular eclipse outdoors in their courtyard. Since I started teaching at prisons, I've fallen in love with teaching to alternative students. So it's really been exciting for me. Again, if your eclipse glasses, if you think they're damaged, you want to take your glasses, put them up in front of your eyes, and look at a bright light. If you see any light at all coming through, throw the glasses away. The only thing you should ever see through these is the sun. Any other light would be too dim unless there's a puncture or a perforation in the aluminum mylar. If you have kids, keep these away from kids until the eclipse day, because you know what kids do. They'll find some way to bend them and break them. So you want to only give them to the kids when you're in the spot where you're going to be to watch the eclipse. Again, I can't stress enough how important it is to see totality, because it's the coolest thing you'll ever see in your life, bar nothing. I tell people, why would I travel halfway around the world to see something that lasts 4 minutes, 5 minutes, 3 minutes? So it must be really cool if people fly around the world to see these things. We've got one literally in our backyard. So there's really, unless you absolutely can't leave for whatever reason, you really need to take the train, to avoid the congestion on the roads. If you're a teacher, check in with your administrator. Tell your administrator why you need to see an eclipse. If you have a problem with that, let me know. I've got form letters. I've got form letters I've written for teachers to give to administrators, for teachers to give to parents. I have a lot of activities, STEM, NGSS, NASA lessons. I've got a ton of things. And by the way, this library system has really good resources too. I was checking them out before. I'm really proud of what you all did with the library system with your resources. Very good stuff. Invite a local astronomer to come to your school or to your house even. We geeks like to travel everywhere and give out information to people, things like that.
Charles,
Remember,
I'll
guys.
give you your 2-minute warning.
Okay, thanks. And again, here's a bird's eye view of the eclipse, what it's going to look like going over North America. Again, this is much speeded up, but you can see the almost circular path of the moon, and how some cities, if you're in the center, you get extended totality. If you're just on the edge, you don't get much totality at all. That's why, even though you may be real close to the southern limit in Ithaca, you really want to drive in and get yourself the maximum amount of totality as possible. And leave. Okay. Oh, okay. That's no. Okay. That's it. Again, no. Yeah, Nova. I did a show for Nova last week. Nova PBS has a wonderful website too with resources too. So there's plenty of websites. Anyway, so that's if you have any quick Q&A, I'll be available afterwards if you want to stay. If not, thank you very much for having me, and please get yourself to totality. Thank you so much.
Yeah, good advice. So we do have a minute or so to take any questions that you might have. I did get one in advance from registrants, so I'll pose that to you. What happens on the moon during solar or lunar eclipse?
What happens? What?
On the moon.
Oh, they see an Earth eclipse. They see the Earth have a tiny little shadow on moving across. So it's like the way we would see a lunar eclipse. They would see Earth eclipse, I guess you call it.
Uh-huh. I'm wondering if that rover, if it's in a position to take any photographs of that.
That would be really cool. I just thought of that now when you said that. I got to look into that. That'd be, how cool would that be? The first time we see the shadow on the Earth from the moon.
Yeah.
That's really cool.
Yeah.
So that's all the questions. I could turn it over to Trey or to you. Back to you, Jessica.
Yeah, I'm not seeing any other questions. So enjoy your eclipse experience. And I
will. I hope everybody. I'll check in with all of you to see how yours was too.
Yeah. Thanks so much.
Thank you so much.
All right, so now we're going to learn more about Eclipse Soundscapes from Dr. Trey Winter III. He is the chief scientist and co-founder of the ERISA Lab. Thanks for joining us.
Sure. Let me just get mine up. So as Jessica mentioned, my name is Dr. Winter, but everybody just calls me Trey. And I'm here to tell you about the Eclipse Soundscapes Project. It is a project that is NASA funded to study how eclipses impact wildlife on Earth. But we also have a special mission going along around that includes accessibility and inclusion. So I'm going to tell you a little bit about the project. I'm going to tell you about how you can participate and how you can actually work with your communities to participate as well. And then I'm going to go into some ideas on how you can be a facilitator, how you can work with your communities, and some of the materials that we've made available for you to engage your communities with eclipse science. And then I'm going to tell you a little bit about another project that you can work with that partners with us a lot, and then answer any questions that you may have. But before I do, again, this is going to be scary because I am doing something off the cuff, and that's never a good idea. But Charles gave us a great overview on what eclipses are, what causes eclipses, and he told you why you should be excited about these things. I thought I'd show a quick video, that doesn't really highlight what an eclipse looks like, but the reaction to eclipses, because I don't think that you can really understand how an eclipse impacts a community unless you've experienced it or seen it. So this is just a little video from 2017 in Casper, Wyoming. So, and I'm going to reshare to make sure I share it with sound, because I always forget that. Share sound, because the sound is important.
Are literally cheering as this takes place. This is just a phenomenal feeling.
It's hard to describe what it's like being inside the path of totality.
People here are literally cheering.
Within minutes, day turned to night as the temperature dropped. right before an amazing show high in the sky.
It took your breath for a minute.
Yeah, I was like, and then I was like, oh my God, this is really happening. And before I knew it, it was over and I was sad.
Okay, so there are three things I want you to take away from that little video clip that I showed. One was just the power of the reactions of the people, right? All the all the yelling and hooting and hollering that was going on. These are amazingly impactful events. The second thing is, in a lot of those images, remember those were taken in the daytime, but it seemed like twilight. And that last little part of the clip really showed how much the light actually changed. It's not just a cloudy day. It is really the difference between day and almost night. Lastly, they mentioned in that in that clip about how the temperature suddenly changed. And one of the things that the Eclipse Soundscapes Project is based on is that eclipses not only are a visual experience, but they are a multi-sensory experience. Since the sun provides 99.9% of the energy that life uses on Earth, that is bound to have a huge effect when that light source goes away at a different time than usual. Temperatures change, but also wildlife react to that change as well. And that is what we're studying. So I have got a talk with lots of resources in it, but I won't make you take notes. And I'm going to put a link in the chat right now on where you can have a copy of this entire talk and all the resources listed in it. There we go. All right, so the Eclipse Soundscapes Project is a participatory science project. Now, you might not have heard of participatory science before. It used to be called citizen science. That's going through a name change. NASA hasn't actually changed the name in most of its documents yet. But basically, a citizen science or a participatory science project is just a project where professional scientists, people who get paid to do science for a living, work with members of the general public to do science that would not be capable of being done otherwise. We actually engage with the public, not just to learn about eclipses and science, but to actually do the science with us. And that is a change from a lot of the different projects that you may have heard of. So since we're a science project, science relies on asking very specific questions and then having a strategy to answer those questions and prove or disprove hypotheses or what people think about the answers to those questions might be. So our question is, how does life on Earth, specifically wildlife, respond to solar eclipses? And even more specifically, we're studying crickets. Now, this is a grasshopper that I've got on my image, but we're really studying insects because insects have a much stronger reaction to day-night cycles and changes in their circadian rhythms. Whereas things like wolves or humans, they might actually be more prone to not have such an immediate change due to the light and dark. And as Charles said before, an eclipse will last somewhere between a minute to 4 minutes, depending on where you're at. On this slide, I have a map of the 2023 eclipse and the 2024 eclipse. And then you can also see the 2017 eclipse. And as Charles said, we're very lucky that we've actually had two full total solar eclipses within a 7-year stretch. And then we had an annular eclipse in October of last year. And we use that annular eclipse as a way to actually test everything out in order to make sure that all of our systems work and to get ready for this eclipse that's going to happen on April 8th. And so we were really lucky. The idea of studying how eclipses impact wildlife isn't really new to our project. It's actually based on a much older study that was done during a 1932 eclipse, and the paper was published in 1935. And a naturalist, somebody who studied the natural world, named Wheeler, actually in Boston area magazines, New England magazines, put out an ad asking for people just to record their experiences of the eclipse and monitor how wildlife around them changed. And in that process, they learned a bunch of different things. Now, again, this was the 1930s. They didn't have the internet, they didn't have social media, and they didn't have the electronics that we have today. So we're recreating parts of that study, but using all of the new tools that we have available. And just like this project, which I think is the first example of participatory or citizen science, we are engaging the power of using the community, the public, and their knowledge of their place to better understand how the impact that eclipses have. And as I said, those impacts aren't just the change in light levels. One of the things that we learned, if you read the paper and all these journal articles, people did actually, note the extreme changes between light and dark, how sudden it came on, how it was twilight during the day. But that was not the only thing that they noticed and reported on. There were many, many reports about changes in animal behavior, both in how people saw them. There is a report of turtles mating during the eclipse. That's actually a very famous paper that was done during some previous eclipses. Birds suddenly taking flight, but there's a lot of sound data as well. Bees actually buzzing as they go towards back to their hives. I myself in 2017 was in a place in the middle of nowhere, Nebraska, on the verge of a bunch of cornfields and at a wetland. And during the eclipse, we were all in awe. We were just like the people in the video that you just saw. And all of a sudden, we noticed that owls started hooting in the background. The owls were waking up because they thought it was twilight and time for them to start hunting. So it's not just what you see, but it's what you hear. And as mentioned in that clip, it's also what you feel. A lot of people have reported temperature changes. There are also lots of anecdotal reports about wind variations, winds actually picking up during an eclipse. So all these things that people have talked about, have mentioned over the years, we are trying to study in a very rigorous scientific way. And we are inviting members of the public to do that with us. So we have many different ways that you can participate. And we want you to work with science subject matter experts in order to learn more about the eclipses and also collect data during the eclipse, submit those observations back to us. And then after the eclipse is over, we'll have opportunities for members of your community to actually go through the data with professional scientists and help them analyze the data so that they can make conclusions about the observations that were made. Now, I mentioned that we've got another mission, and one of the centerpieces of the Eclipse Soundscapes Project is our focus on inclusion and accessibility. So Jessica mentioned that I am a co-founder of the ARISA Lab. ARISA stands for Advanced Research and Inclusion and STEAM Accessibility. And if you're not familiar with the STEAM acronym, that's Science, Technology, Engineering, Arts, and Math. And our goal is to make NASA science experiences that are inclusive and accessible to everyone, including a very strong focus on people who are blind or who have low vision. We have a partnership with the National Federation of the Blind, and they review all of our products and all of our methods and procedures and communications to make sure that what we are sending out is accessible and usable by the blind and low vision community. Now, we work with them to make sure that we are making things with that community, not just for them, but that focus on inclusion and accessibility doesn't mean that others can't participate as well. One of the main things that ARISA really pushes for is universal design of learning and using tools so that the accessibility and inclusion supports that some groups might need in order to participate go in to also serve others as well, to make sure that there's a better experience for everyone. And one of the reasons why the National Federation of the Blind is so excited about our project is that it's one of the few projects that isn't just for them, but allows them to participate with their sighted peers as well. And as I mentioned, we are revisiting that 1935 Wheeler study, but we also worked with the National Park Service in 2017 and they were able to do recordings in 18 different national parks along the path of totality for 2017. So we used those recordings as a baseline to do our experiment. But the two experiments are very different. They had professional soundscapes ecologists. Soundscape ecology is a form of science where you can actually learn about the health and well-being of habitats and the life and animals that live within those habitats by just studying the changes in the sounds that they make. And it is amazing how much data you can pull from the ambient sounds of a habitat. So they had professionals doing that one, and they were only able to do 18 different sites. We have shipped out in the last week over 222 audio moths to sites all along the total solar eclipse. In 2024, we are working with the Nature Sounds group, who will be actually doing recordings at another 96 sites. We have another partner in Texas who is working on another 20 sites. And we distributed over 176 kits for the 2023 annular eclipse. And about half of those are in regions that actually get both the annular last year and the total this year. So we're hoping to have in excess of 300 different recording sites. So that's far more than the National Park Service was able to do alone. And that is the power of participatory science, getting the public actually engaged, getting communities engaged to help us learn more. And it would not be possible otherwise. So how can you get involved with Eclipse Soundscapes Project? So we have many different roles, and this is where the inclusion aspect comes into it. We realize not everybody's going to be on the path. Maybe not everybody has the time to participate at the highest, most demanding levels. Maybe, there are some cost considerations. So we've tried to have different ways that everybody can participate in one way or another during the eclipse and after the eclipse. Oh, sorry, and before as well. So the first way that you can participate is you can do our free online apprentice training. So during this training, we have materials that are accessible that actually teach people about eclipses, not only why do eclipses happen, but why there are different types of eclipses and what effects those eclipses actually have on Earth. So all of that is freely available on our website, and our website is eclipsesoundscapes.org, and I am going to drop that link in the chat as well when I'm at the end of this talk. And at the end of that training, if you finish all of the training and do a little quiz at the end, you can actually get an Eclipse Soundscapes, a NASA certificate of completion saying that you are now an official Eclipse Soundscapes apprentice. So it's got a nice little NASA logo, and it is something that people can actually earn, and it can be a way that for you to engage with their community so that there's actually an outcome and something that they can take away. The second way that people can participate is the observer role. Now, the apprentice role can be done anytime before or after the eclipse, probably more useful before, but the observer role is an eclipse day activity, and it was specifically designed to be a low-lift activity that community groups could actually engage with their communities and do an activity that was fairly easy and that had almost no monetary costs at all. So an observer role is actually recreating almost directly that 1932 Wheeler study. And we are asking people to have a mindful, multisensory eclipse experience. And we have field note sheets, which you can download from our website, and actually just journal what you experienced during the eclipse. And we have some guided questions. Do you hear changes in insect sounds? Do you hear changes in the sounds that people make? Do you feel the temperature change that people talk about? So this is very much qualitative data, the data of human experience that people can actually do on eclipse day while still, as Charles said, just enjoying the eclipse. In fact, we think that by having this multi-sensory eclipse, actually just experience, by actually thinking about not just one senses, but all of them, it'll actually be a deeper and more rich eclipse experience for all of the participants. And again, once you submit the data on a web form, you get another certificate, a NASA certificate of completion. The third way you can participate is by being a data collector. Now, this is an activity where We have sent out the kits that I mentioned, and each of the kits contains one of these audio moth data recorders. And these are scientific grade devices that take 3 AA batteries, and everything that you would need would be in the kit. But it's basically the 3 AA batteries, a micro SD card to actually store the data, and a Ziploc bag with 3 zip ties on it. And what we're asking people to do is to find a place where they think animals might be making a lot of sound, where they've heard crickets before, where they've heard birds before. Put the batteries in, set it up to go, put it in a Ziploc bag, and zip tie it to a tree with the permission of whoever owns that land, of course. And I don't know if this really comes across, but these are inexpensive data collectors. They're all open source. But what we have done is we've added these silicone bump dots to it and a Braille label. And what that allows us to do is to make this a device that people who are blind and low vision can actually use independently without somebody telling them what's going on. And these silicone bump dots are actually used by the blind low vision community a lot for wayfinding. Because they come in lots of different shapes and sizes, and we've got like a square one, a cylindrical one, and a rounded one on this, so that you can find the switch, you can find the SD card, and you can find the USB port really, really easy. I can find it without even looking on this. And then the Braille lets people know what the Audio Moth ID number is. And I'm really an evangelist for these, because for just pennies and just with some thought and foresight, you can make lots of different things accessible to people who are blind and low vision with very little effort. Now, unfortunately, we have given away all of our free kits. The timeline to actually receive those ended in January 31st, but you can make your own kits. And I'll talk about that a little bit later. So you can do it on your own, unfortunately, and then still participate in that way. But we don't have any more free kits to give away. And then the last way to participate, again, is the data analyst role. That's going to be available shortly after the Eclipse. Once we start getting the data in, we have an accessible way for people to go through and actually listen to some of the eclipses and add metadata to the data. That's information about the data. What did they hear in there? Did they hear people? Do they think they heard crickets? And that will help guide scientists to the data that they need. So more information is going to come out about that right after the Eclipse. Oops, there we go. Now, we love working with libraries because we don't know your local communities, and we don't have the staffing levels to be able to work with all the different communities, all the different 300 locations all across the path of totality and just outside of the path of totality. Oh, and I should say that you can actually participate in all of these roles, either inside or outside the path of totality. We did send all of our free kits pretty much to within to 75% or above, and really focusing on the path of totality. But if you're off the path, you can still actually participate in all these other different roles. We have a whole section on our website for libraries and how you can actually work with your communities as facilitators for some of these Eclipse activities. The first one is, of course, the apprentice activity and leading your groups through all the different resources that we have online to find out more about eclipses. And then if at the end of that, you can actually print off those certificates of completion for all the different attendees. We actually worked with a lot of libraries, and again, I'm sorry, but we're out of the free kits, but lots of libraries across the path of totality got our kits. We really tried to work strongly with a lot of library groups, and you could guide them into becoming data collectors. So the idea here is that you work with the community, and maybe you only have 1 or 2 audio moths, but a group actually gets together, learns about why we're doing this study, and determines the best place to actually position those audio moths for the best possible recordings. That's the last one. And then the last one is being an observer. So actually having groups of people actually experience the eclipse together, or doing trainings before the eclipse and passing out these field guide notes, which are easily printed off. They're in PDF format, but the PDF format is also an accessible PDF format. So if you share the file, people who use screen readers should also be able to work with those PDF files as well, and train them on how to have that multisensory experience. And we have training on what that actually means, and helps guide you through working with your local communities in order to do those training. And again, at the end of all these things, if they submit their data via the survey forms we have online, they get a NASA certificate of completion. So that is the Eclipse Soundscapes project, kind of in a nutshell. It's a little bit of a rushed version. I can talk about it for hours and hours. We've really worked hard to make sure that we actually include as many people as we can in doing eclipse science. But we're also working with our partners at NASA who are doing other participatory science projects. We are funded by the NASA Science Activation Program, and that program is really focused on actually engaging the American public in what NASA science is and doing NASA science with NASA scientists. And we all work together to achieve that goal. And the slide that I have up right now is for a Globe Eclipse. It is a citizen science project that anyone can participate on. This is something to be done on the day of the eclipse. If you're familiar with Globe Observer, they have lots of citizen science projects that are cell phone based. Mosquito Mapper is a famous one where you can actually send in mosquito reports and take pictures of mosquitoes to help people track how mosquito migration is changing as a function of climate change. And that's very important since mosquitoes are a huge vector of diseases. But they've got a special program for eclipses where they're asking people to monitor thermometers and using the app to actually record that temperature change that people have been talking about for centuries and actually help them kind of quantify it. And this is really useful for our project because you always have to minimize the variables, minimize what kind of what changes, so you can know what change actually had impact on the thing that you're studying. And by teaming up with Globe Observer Eclipse, we can say, hey, was it the light levels or was it the temperature change? You know, what changes, how did these interact in order to make the changes and the wildlife sounds and patterns during the eclipse? So that's another great program. Almost everybody has a smartphone nowadays. And again, this could be another activity that you work with your patrons at your local library and educate them about why they're doing this and actually have them participate in real meaningful NASA science that will lead to publications in the future. So they can not only learn about the eclipses, but be part of NASA and be a NASA scientist doing real science during the eclipse. So that's all that I have prepared for today. I highly suggest that you go to our website, eclipsesoundscapes.org. I'm about to put a bunch of links in the chat so that you can have access to all of those. We have a lot of YouTube videos up. You can find them all on our webpage that go through the process, our project, and how you can lead your communities through the different aspects and participate in the different roles. And with that, I'll turn it back over to Jessica.
Okay, thanks, Trey. So feel free to post questions into the chat. I'm also going to put a couple links in here as well. So there's a link to a brief webinar survey, and I also want to invite everybody to our final program in the series. That's going to be on Monday, March 25th, 10 to 11 a.m. And it's called Raven Steals the Sun, Native American Eclipse Stories. And that's going to be in person at the Tompkins County Public Library, or you can tune in on Zoom. So we did have a couple of questions from registrants in advance. So one of those was, what animals in upstate New York should we be trying to observe? So I know you mentioned a few here, but any animals or insects that you think would be most interesting to focus on?
So one of the things that we really are focusing on is not just studying one species, right? We chose crickets for our minimum viable product study because crickets are ubiquitous and they should be all along the path of the US. As long as the temperatures are above about 55 degrees Fahrenheit, they should be active. And that's something that we can then study all along the eclipse. But we also are working, and this is where soundscapes ecologists are really excited. is that we are creating the largest soundscapes recording taken at about the same time as ever been done. This is going to be a hugely impactful database in the field of soundscape ecology. And after the end of this project, even during it, we are making all the data public so that everyone can actually access it, listen to it, do their own studies using Rainforest Connection. But we're also making it open, which means that we will have ways for people to download all of the data to not only use for their own studies, their own interests, but also for art, whatever purposes they want. The data is free, sponsored by NASA. So thank you very much for your tax dollars. We're hoping we're putting them to good use. So I wouldn't say focus on, I'd say don't focus on what we're interested in. We're going to get cricket data. There's almost guaranteed to be crickets in the background. Focus on what you think is exciting. Focus on what you think really might be interesting. Like if you know that you hear a certain species of birds every day, put those recorders out. And we ask people to put the recorders out 2 days before so that we get some baseline. And then during the eclipse, we can see what the change is. And then hopefully the recorders can stay out 2 days after so that we can see if after the eclipse, does that change? Is there like an effect that lingers on past the eclipse as well? So again, focus on what you think is interesting because we're going to get the data we need, but we also want to build up that database for others. And I should also mention too that, and I forgot to mention this before when I was talking about the facilitators roles, we have a quick startup guide. So we made a PDF that, oh, that's the YouTube video, not the startup guide. We have a startup guide that you can access and use to actually help you start planning your events. So that's something that you can use to just really get up and running really quick. And again, that observer role is made to be low lift, easy to do, very little preparation and planning.
Great. Well, we're going to add all of these resources into a live guide that's been compiled, and we'll send a link out to all of the participants here today, as well as we'll be sending out a link to this recording. So if you missed anything, you'll be able to get that as well.
And Jessica, one of the participants direct messaged me wondering if Charles' presentation was going to be available, if his PowerPoint would be. I think, Charles, you're still here.
Yeah,
Maybe.
I saw that. I was thinking about the recording, but yes, we'll ask for a copy of the slides as well to share that if we can.
Okay.
Yeah, that's fine. I can certainly do that. That's fine.
Thanks. And then the only other thing. Oh, I'm getting feedback. I was just going to mention that we are going to be releasing a mini grant this week to help our library and cultural organizations pay for supplies if they wanted to engage with something like this kit or if they have other activities in mind. And so be on the lookout for that.
That would tie in well with the Eclipse Soundscapes for sure.
Yeah, and I'm sorry that we don't have enough kits for everyone. Like I said, we've sent out almost 400 kits during this project. But we also, as part of the inclusion aspect, we try to make sure that the kits were as low cost as possible. So the cost of the kits will be under $150. It's Ziploc bags, it's zip ties. The audio mounts are the most expensive part. And that cost is hard to calculate because even though they're open source, there aren't many people who make them. We have all the resources to find all the materials on our website, eclipsesoundscapes.org, but they cost anywhere between $90 and $100. So there's a place called labmaker.org where you can order them, and the delivery time is somewhere between 2 to 3 weeks. So keep that in mind.
Good to know.
But just so you have some idea of the cost, should be really under 120, but somewhere around that range.
Thanks. Well, thanks so much to Charles and Trey for joining us and sharing all that information. And thanks to all of our participants today. And we'll be in touch later in the week with all of these great resources. So thank you, everyone. Have a good afternoon.
Thank you very much, everyone.